Hi everyone. Two vectors may be added to each other by taking the vectors in turn and placing the head of the first to the tail of the next. The resultant vector is the line joining the tail of the first vector to the head of the last vector. Okay, so let's look at these questions. Determine the magnitude and direction of the resultant vector. So step 1, we need to draw the vector diagram. So here we have 2 newtons upwards and then 4 newtons south. So I'm just going to move a little bit to the right so you can see the next vector, which is 4 newtons south. And the resultant vector is from the start. So this is the starting point to the end. So this is our resultant. And we need to know what is the value of this resultant vector. So here the resultant equals to, so we can just take vectors upwards to be positive and vectors to the right to be positive, but vectors to the left and vectors downwards are taken to be negative. So here we have 2 upwards, so plus 2, and 4 downwards, so minus 4, and this equals negative 2 newtons, which equals 2 newtons downwards. Or we can say 2 newtons south. So the magnitude is 2 newtons and the direction is downwards. If we look at example B, we have 10 newtons east plus 5 newtons west. So we have 10 newtons east and then 5 newtons west. As we can see, we connect the two vectors from head to tail. And the resultant is from the start to the end. The resultant is from the starting point to the end point. So this is our resultant. And we can see from the vector diagram that this resultant is equal to 5 newtons. Okay, we have 10 newtons minus 5 newtons. This will give you the remaining value, which is 5 newtons. So the resultant equals 10 minus 5. This equals to 5 newtons. And the direction is to the right, or we can say east. Question C, 29 meters per second south plus 19 meters per second east. So we have 29 meters per second south and then we have 19 meters per second east. So as we can see, I connected the two vectors from head to tail, and the resultant is from the start to the end. So this is the starting point. From the start to the end is my resultant. And we also need to know the direction of this resultant. So in this case, the resultant is starting from here, so we need to find the angle theta. And in this case, because we have a right angle triangle, we can use Pythagoras theorem to find the value of r. So r is equal to the square root of 19 squared plus 29 squared and this equals to 34.7 meters per second, and tan theta is equal to opposite over adjacent. So we have opposite, we have adjacent, so we can use tan ratio to find theta. So tan theta equals 19 over 29. So therefore theta equals tan inverse of 19 over 29. So theta equals tan inverse. Opposite is 19, adjacent is 29. So 19 over 29. And using the calculator, we get 33.2 degrees. But in this case, we need to tell where this 33.2 degrees is located. So if we look at our vector diagram, this angle is between south and east. So we say south because the angle is starting from south, and then 33.2 degrees, and then east. So the magnitude of the resultant is 34.7 meters per second, and the theta, the direction, is south 33.2 degrees east. Question D, we have 50 meters north plus 20 meters west. So in this case, we have 50 meters north and then 20 meters west. And the resultant is from the start to the end. So from here to here. This is the resultant. So in this case, we also need to know the direction of the resultant. So theta will be located next to the tail of the resultant. So this is theta, and we will need to calculate the value of theta. So the resultant equals, again, here we have Pythagoras theorem because we have a right angle triangle. So the square root of 20 squared plus 50 squared, and we get 53.9 meters. And theta will equal to, again, I will use here tan ratio because I know the exact value of the opposite side, and I also know the exact value of the adjacent side. So I will use tan ratio. So tan theta equals opposite is 20 over adjacent, which is 50. And therefore theta equals tan inverse. Opposite is 20 and adjacent is 50. So tan inverse of 20 over 50 is equal to 21.8 degrees. And now this angle is between north and west, and the angle is starting from north. So we will need to say north 21.8 degrees west. For this question, we have 12 meters at north 40 degrees east plus 3 meters at south 30 degrees east. So the first vector is 12 meters at north 40 degrees east, and the second vector is 3 meters at south 30 degrees east. So as you can see, I connected these two vectors from head of the first vector to the tail of the second vector, and my resultant is from the start to the end. So in this case, do we have a right angle triangle? Let's find out. If this angle is 40 degrees, then this angle here is also 40 degrees. So this is 40 degrees. And 40 plus 30 degrees is equal to 70 degrees. So this total angle is not 90 degrees, is equal to 70 degrees. So in this case, we don't have a right angle triangle. Okay, so we need to use cosine rule in order to find the value of the resultant. So in order to use the cosine rule, in order to find this unknown r, we need to know the angle that is opposite to r, and in this case we have the angle that is opposite to the unknown side, which is 70 degrees, and we also need to know the other two sides of the triangle, and in this case we have the two values, 3 meters and 12 meters. So R is equal to the square root of A squared plus B squared, so that's 3 squared plus 12 squared, minus 2 times A is 3, B is 12, cos theta times cos theta. Which theta? Theta that is opposite to the unknown, which is 70 degrees. If we use the calculator and we press cos, the calculator opens a bracket, so make sure you close the bracket. So the answer is 11.3, and the unit is in meters. Because these two vectors are in meters, therefore our resultant is also in meters. And now we can't use SOHCAHTOA to find the angle because we don't have a right angle triangle, so we can't use sine, cos, and tan ratio. But we can use sine rule in order to find the angle. So step 1, I will find this angle theta using the sine rule. So sine rule is sine theta over the opposite side. So opposite of theta is 3 meters, so sine theta over 3 equals sine 70 over the opposite side, which is the resultant, 11.3, or I can see here 11.33, so I will put 11.33. So here we have one equation, one unknown, we can find the unknown. So we can cross multiply. So 11.33 times sine theta, we get 11.33 times sine theta equals 3 times sine 70. And now sine theta is equal to 3 sine 70 over 11.33. Okay, so here because I don't have space, I will just make theta the subject. So theta equals sine inverse. The right hand side is 3 sine 70 over 11.33. Again, when you press sine, the calculator opens a bracket here for you, so you need to close that bracket. So the value of theta is 14.41 degrees. But this angle, as we can see, it does not start from a major point. It does not start from north, and it does not start from east. We need to find the value of angle from either north to the resultant or from east to the resultant. So we can say north, the value of the angle east. Okay, so in this case, we can find the angle from north all the way to the resultant. I will call this angle alpha. So we need to know what is alpha, which is from north to the resultant. And in this case, the value of alpha equals 40 degrees plus theta, which is 14.41 degrees. So 40 degrees plus 14.41, we get 54.41 degrees. Okay, so now if I draw my compass, this is my resultant. This angle here is 54.41. Alright, so now we can say, and this is my resultant, now we can say north 54.41 degrees east. Okay, so this angle is between north and east, so we write northeast. So because the angle is starting from north, so that's why here I wrote north first, and the angle is 54.41 degrees.